Guys, in this presentation we want to do some more work with present value. Remember, economists believe that you have to use present value anytime a firm is considering an investment because we have to somehow get that future revenue from the output, that future MRP that might be earned if the firm makes this investment. We have to take it from its future terms and bring it back into today's terms so we can compare it with today's costs. Present value is just one of the things that we have to think about when a firm is making an investment. Other things that we really have to consider, other elements, you have to think about MR, the added revenue that you're going to get from this extra output. You have to think about MC, the added cost of that. You have to think about the added output itself, MP, the marginal physical product. You have to think about the MRP and the MRC. That's ultimately what we're thinking about. So we want to do some examples right now. We want to put some numbers in here in order to kind of see how present value works. Now we want to emphasize something. Nowhere in present value is the MRC. Nowhere in the equation for present value is the added cost of making that investment. See guys, we use the present value of the future MRP and we compare that with that MRC. So the MRC is not in here anywhere. So we want to get the present value of MRP so we can compare it with today's MRC. So let's put some numbers in and see how it works. So let's say that I want the present value of $100 to be received a year from now. So let me emphasize this. So our firm's going to make an investment. I'm not sure how much it's going to cost right now. But I think from this investment, we're going to earn an extra $100. If this is not exciting, just add the word million at the end. It's going to make another $100 million. So I think I'm going to earn $100, and I think I'm going to receive it all at the end of 1 year. So that $100 is my future value. And let's say for this investment I have to pay 10%. To decimalize 10%, it's going to be 0.1. Hey guys, anytime you're making a decimal and you're not sure, just take the percent in number form, divide it by 100, and the decimal will always go in the right place. So I know that for 10%, it's 0.1. So this is going to be 100 over 1.1. So I want to know what the present value of $100 is to be received 1 year from now. I don't need that 1 there because I'm raising it to the first power. At a rate of 10%. Let's do it again. The present value of $100 to be received 1 year from now at a rate of 10%. Hey guys, other things being equal, if I make an investment right now and it's going to generate $100 for me in extra revenue from extra output in the future, and I get it all paid at the end of the year and I have to pay 10% for it, that present value is $90.91. Now listen, if everything goes great and we actually get the $100, we're going to physically get $100 a year from now. But because we had to wait a whole year, and because we had a carrying cost of the interest of 10%, the year and the 10%, that money, that physical $100 is only worth about $91 to me today. So if everything goes right, we physically get the $100, but the present value of that $100 is only about $91. That's how present value works. The present value is always less than the future value because there's no such thing as a zero interest rate. So what we're saying is, if we make an investment today and we think it's going to bring us an extra $100 a year from now, and it's going to cost us 10% to make that investment, the present value of that $100 to be received 1 year from now is $90.91. So as long as my marginal resource cost is less than or equal to $90.91, I should make that investment because the present value of MRP is greater than or equal to the MRC. Hey, let's try it with another percentage rate just to see how the percentage rates work. Let's keep everything the same except change the percentage rate. Let's say I want to know the present value of $100 to be received 1 year from now at a rate of 5%. Now be careful when you do percents. 5% is 0.05. If you do 0.5, guys, that's 50%. So 0.05. So if I do $100 over 1.05, I get $95.24. $95.24. Now again, if everything goes right, we make this investment, it's going to generate more output and more revenue in the future, and a year from now we're going to have an extra $100 from this investment. But because I have to wait a year, and because the carrying cost of that capital is 5%, that $100 that I'm physically going to get, that I think I'm going to get at the end of the year, it's only worth $95.24 to me today. So we've built an interesting relationship. We can see that there's an inverse relationship between present value and term. Forgive me, I misspoke. Present value and interest. Present value and interest. An inverse relationship between present value and interest. When the interest rate is 5%, the present value is a little over $95. But when the interest rate is 10%, the present value is only about $91. So every time the interest rate goes up, the present value goes down. When the interest rate goes down, the present value goes up. Hey guys, what that means is firms that pay a lower interest rate can make more investments. Hey, let's do one more change so we can see how present value works. Guys, I want to go back to the 10%, but I want to make our investment for 3 years. Now listen, we're doing everything coming in at the end of the investment. So everything comes in at the end of 3 years. So everything else has stayed the same as with our first example. We're going to make an investment, let's say. We think it's going to bring another $100. If that's not exciting, make it $100 million. And we're going to pay 10%, but it's going to take us 3 years to make this investment pay out. So it's going to take 3 years for this investment to become fruitful, for the firm to get benefit in output and revenue from the investment. So let's see what happens here. So we want to do 1 plus 1 to the third. 1 plus 1 to the third is going to be, let me see, 1.33. Let me make it just a little bit smaller. So 1.1 to the third is 1.33. Now, the present value of $100 to be received 3 years from now. So now it's taking us 3 years to make this investment. So we lay out the cash now, we buy that capital, and it's going to make us another $100. But it's going to take 3 years before our firm gets any revenue. At 10%, that's only going to be worth about $75.13. Oh, $75.19, sorry. I might have made a mistake on this. It might be $75.13, $75.19. It's about $75. So here's the deal. We're building an interesting relationship. The present value of $100 to be received 3 years from now at 10% is about $75. But as we saw earlier, the present value of $100 to be received 1 year from now is about $91. So that tells us that there's an inverse relationship between present value and term. So we talked about two relationships in this video. An inverse relationship between present value and interest, as well as an inverse relationship between present value and term. Important features, elements to think about. MR, MC, MP, MRP, MRC, the present value of MRP, and discounting. We'll talk about all this stuff coming up in lecture. Go to your Zoom meetings. You guys are great. Thanks for hanging in there for the class. We'll see you next time.